In this video, we want to see how we can generate all possible truth tables, starting with 1, then 2, then 3, then 4, and eventually 5 variables. And we see that as the number of variables increases, the number of lines in a truth table also goes up, and the number of possible truth tables goes up also at a much more rapid rate. The first one we want to look at is with one variable, and we see that P is that variable and it can be true or false, and then there can be 4 different answers, and one particular answer would be false true. And this case we see that we'll list trues first and then the falses. With 2 variables, P and Q, we have a total of 16 possible 4-line truth tables. And one truth table, which would correspond to the binary number 1000, is as listed below, where P, again, we throw the trues first and then the falses, and then Q goes true, false, and here's the possible answer that corresponds to 1000, where of course 1 is a T and 0 is an F. Variables P, Q, and R, we have an 8-line truth table where P goes 4 trues and then 4 falses. Q would be 2 trues, 2 falses, 2 trues and 2 falses, and then R would be true, false, true, false, true, false, and true, false. And then a possible answer is, I just picked one arbitrarily, true, false, 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 true, true, false, which corresponds to the binary number 10000110, where we just go in the vertical here and we turn it into a linear line of 1s and 0s. With 4 variables, we are going to have 16-line truth tables, and here's one possible truth table of a total of 65,536 possible 16-line truth tables. And you see that P, we put P, Q, R, and S, and we start with trues, and so we'll have 8 trues and then 8 falses for P. For Q, we'll have 4 trues, 4 falses, 4 trues, 4 falses. For R, we'll have 2 trues, 2 falses, 2 trues, 2 falses, 2 trues, 2 falses, 2 trues, and 2 falses. And then for S, they'll just alternate true, false, true, false, true, false to get all possible values of P, Q, R, and S. And I just picked an arbitrary answer right here, and then that corresponds to the binary number. And in subsequent videos, we'll try to figure out, given this answer, what is the logical expression that would generate that answer. But for now, we just want to list all possible answers and see how many there are. And in this case, for 4 variables, it's a 16-line truth table, and there are possible 65,536 possible answers to list all those answers. For 5 variables, we'll see that we have a 32-line truth table. Our 5 variables are P, Q, R, S, and T. And then here's my answer right here. And again, we'll start with P being moving the slowest, then Q, then R, then S, then T. And that lists all possible values. And then here's a particular answer that I picked arbitrarily. And this answer corresponds to this binary number right here, which is a 32-bit binary number. And we see there's a few more lines that did not make it on the screen, but I scrolled up and we saw that. In general, we'll be working with 2 variables, so I want to summarize the information there. For every 2 variable logical expression, there is a 4-line truth table, and for every 4-line truth table, there is a 4-bit binary number. In general, for every n variable logical expression, there is a 2 to the n line truth table, and for every 2 to the line truth table, there is an n-bit binary number. The student will work with logical expressions and truth tables, but we'll use the computer in Python and work with a computer program. So instead of doing it by hand right here, we'll translate it to a program in Python, and we'll have the Python program solve the problem that the student was working with by paper and pencil here. Now, to get a little bit of experience with doing this, write the truth table for each of the following binary numbers. So that would just be 3 possibilities for you to work on.